Well, hi class. Welcome to your Lab 4 video, which is categorical interactions. And what does that mean, right? A categorical interaction is going to be when we have more than one categorical predictor and still that one continuous outcome. So it would be when differences on the outcome due to predictor 1 are dependent on predictor 2. With some context here, it would be like seeing if we have differences in time spent in therapy between men and women being dependent on what type of therapeutic approach was being used. So one categorical predictor would be gender, and the second one would be the therapeutic approach. So as we move through our lab, we have pretty much a little outline here. For prep, we need to read in the data. It's going to be a tab delimited file, set the measurement type, and load packages for R. When we're in SPSS, we'll add labels and values. Then preliminary, we need to prepare the data set by making a subset, get our descriptives, check out the univariate assumptions, and set up treatment coding so that our data and variables are ready for the regression. With model testing, we're going to set up a regression and look at the main effects and the interaction effects. And when we do have significant interaction effects, we need to look at those more closely and create interaction plots. So that's a little rundown on what we're doing in each section here. So our goals, you'll need your Lab4 script. It starts with the goals that we're just talking about and prep, reading in the data. So I'll start by loading tidyverse. And the packages I'll be using are tidyverse, dlooker, car, emmeans, interactions, and embes. But what we need is this tab delimited file called TherapyTime. And before I go to get the data set, I'm going to copy these levels here because there's 7 levels. So I'll do Control Copy. That way when I import the data set, I can just set up my factor with the levels by pasting it in there. The other predictor, gender, just male and female, that's easy to type in. So I'll start by going to get the data set, browsing to where I have saved the TherapyTime.dat file. So of course it comes in all squished together, and I need to tell RStudio that it's tab delimited. And for condition, that's where I want to paste in these levels that I copied off the script. So I have control, psychodynamic, cog-behavioral, drug, EMDR, TMS, and holistic therapy types. And then for gender, I'll set the factor, which is male and female. And then that is ready to import. I also tend to rename my data sets so I don't have to type them out so far. So if I forgot to do it during import, I can just write code and rename it so that I have Lab 4 smaller than TherapyTime. And this is a good place where you can save your data frame. That way, once you have it imported the way you want it, and you don't want to have to set up the levels each time you import the tab delimited file, you can save your file your data frame, and it will save to your global working directory. So now I'll have it available if I need to stop and come back and work on it later. So again, our preliminary tasks are to get the data set ready. I want a subset of the data because I don't want all of the levels of therapeutic approach that came with the data set. I only want to look at 3. Specifically, I want to look at control, psychodynamic, and cog behavioral. And I want to check out the assumptions, do some descriptives, and basically get ready for the model. So first I'm going to look at the data. I have time in therapy, the average of 27.1 weeks. Conditions, so different therapeutic types are control, psychodynamic, cog behavioral, drug therapy, EMDR, transmagnetic, and holistic. And there's 20 participants in each of those conditions. And then for gender, I have male and female. So the 3 levels that I want from the condition categorical variable are control, psychodynamic, and cog behavioral. And I'm going to use a subset function to reduce the levels and subset the data set. And this is something that can come in very handy for your data projects. A lot of times students will find a data set that has a whole bunch of different categorical levels in a variable they're interested in, but they're really only interested in, say, 3 of those levels instead of 17 of them. So this is a way to drop down levels in a categorical variable to just the ones you're interested in. So first, I'm going to get the subset where in the dataset Lab4, the variable condition, I wanted to select within that variable those that say control, psych-D, or cog behavioral. And then, comma, I'm going to select those 3 variables. So I've got the arguments for what should be subsetted there. And I'm giving it a new name in the environment, Lab 4.1. So now let's take a look at what we have. You'll see here in the console, I have the 3 I want with the 20 in each of those conditions, but it still kept the 4 that I don't want, but with zeroed out. So it dropped the cases, but it still left the level in the data set, which is going to be a problem. But notice that I now have less people here. Now I have 24 and 36 male, female, whereas before I had 64 and 76. So it dropped them, but it kept those levels just zeroed out. So now I'm going to use a function called drop levels to remove the levels that have no observations in them. And I'll call it a new thing in the environment, Lab 4.2. So now let's take a look. I'm down to just the 3 I want, control, psych-D, and cog behavioral. Now I'm ready to move on to descriptives. I've gotten my subset, which is what I needed to kind of condense what I'm looking at. And then now I'm ready to get descriptives on the levels of time in therapy for each of those gender and therapeutic condition variables. So first, I just want to find out average time and the standard deviation for time. And I called that descript. So average time with this subset is 23.82 and standard deviation 10.92. And I'm just upping it to Lab 4.3 to keep my script organized. So now I want to check out the outcome at each level of the categorical predictors. I'll first check it out by looking at gender, and we've done this before where we use the piping tool to get to group by the levels of a categorical variable. That we did the same kind of thing in Lab 3. So when I look at that, I have male and female, the average time in therapy, the standard deviation, there's no missing values, and there's 24 observations for the male and 36 observations for female. I can do that same thing looking at therapeutic approach, which is the variable called COND. That's gender, there we go. So in the control condition, average time was 35 weeks, and there were 20 observations in each one of those categories. Psych D, average time was 22.9, and Cog Behavioral, average weeks in therapy was 13.20. So I have a lot of information to start working with my table. We also got cell means, similar, that we did in Lab 3 with the single cat. We can do the same by having both the gender and condition in the same table. So then I have it broken out by both gender and therapeutic approach, the average time spent in therapy and the SD. So that's a lot of descriptives that I can use to start working with my tables, right? And now I want to check those assumptions. The assumptions of normality of the continuous outcome, time in therapy, for each of those categorical predictors. So I can visually inspect the histograms. Here's the one on gender. So I have male and female for gender, and then I have the one on condition. Now when they're together like this, it can be hard to see what they actually look like. There's a function called facet grid that puts the graphs in separate positions. Let me show you what this looks like. And this is in your in that R for Data Science, the OER book that we have as part of the class. So here's facet grid, taking each of those histograms and breaking them out beside each other. So Cog Behavioral is very spiky right here at the bottom. Psych D is a little more, still spiky, but a little more rounded, and then control seems very skewed. After your visual look at the histograms, we want to also check out just the Shapiro test. And again, by each level of the categorical predictor. And you've done these before in Lab 3, so I'm kind of speeding through a little bit. We have that a non-normal distribution for male and female, that the Shapiro-Wilks test came back significant. And checking for this one, we have 2 significant Shapiro-Wilks for control and Psych D, but Cog Behavioral said that it was not unequally distributed on the outcome of time spent. So that's one assumption check. One of our univariate assumption checks was normality of the outcome across those different levels of the categorical predictors. The other one is homogeneity of variance. How spread is it? So here we look at the bar graphs and box plots and things like that. Here's another building onto your graphing skills. Usually when we do a bar graph, it's going by count, by how many, and we already know there's 20 in each condition. and that's not any new information. But we want to know the mean and how the mean is distributed. So this says ggplot, use the 4.3 data set, use a bar graph with gender on the x-axis, time on the y-axis, use a fill of gender so that it's got different colors per gender, and instead of count, use a summary statistic. Which one? The function of mean. Looks something like that. So instead of count on the side, now it's got average time spent in therapy for the male and the female. We can do the same thing with condition. And now we have average time in therapy per therapeutic condition. And of course, our box plots that help us look at the spread of the scores. Male and female. We have a much wider spread on female than on male. And the middle bar is the median. And then also for condition. And here we can see some big differences between the median for control, the median for psychodynamic, and the median for cognitive behavioral. And also differences in spread, but that one's the tightest. And here's another tip for working with graphs in R. You can add labels, like your X label, your X-axis label, your Y-axis label. You can add a main title to your figure while you're telling R what to do with that plot. So then it would have like prettier labels. And after you've looked over your box plots and bar graphs, looking at the spread there, we want to also run the Levine's test. Oh, I have one more box plot for you guys. And this one we saw before in Lab 3. Okay, Levine's test, we're going to need the CAR package, and we're looking at, does gender violate homogeneity of variance? When we run that, we see our p-value is 0.01, so yes, it violated homogeneity of variance because there's a significant Levine's test for gender. Let's see for condition. And yes, there's the p-value that's very, very, very small because it's to the negative 0.05 power, so that's the decimal point being moved, scientific notation. So these both of these categorical variables violate homogeneity of variance, and we just want to tell the reader that in the write-up. So let's see how we're doing. We read in the data, we got the measurement type set when we set up the factors, we loaded packages, we got our subset, got some descriptives, and we checked out univariate assumptions. The next thing we're doing as we're going into model testing is setting up the treatment coding for the categorical predictors. Now, one thing, for R, treatment coding is default. In other words, we never had to set up treatment coding specifically, because soon as we say we have a categorical predictor in the equation, R is going to treat it as treatment coding with whoever's first as referent. So let's take a look and find out what they are naturally. So contrast for condition and for gender shows us that control is referent for the therapeutic conditions, and male is referent for the gender. So we'll just run with that. Our first regression will be with the referent control and male. And I named this one time by control male so that I'll know what it is in the environment later. This is the linear model of time predicted by treatment condition and gender. Now notice here I have a multiply. This is different than before. This is so that we get that interaction term included. It used to have, like when we did multiple regression, we had the outcome predicted by predictor 1 plus predictor 2. And that's fine for mean effects. A mean effect is the change due to just that predictor. But now we also want interaction effects. And to get that, we need to use a multiply, an asterisk there instead of plus. And then using the Dataset 4.3. So I'll get a summary of that. And let's take a look. So our intercept, just like treatment coding, is about the referent. The referent is in control condition as far as therapeutic approach and male. So for males in therapeutic in the control condition, the average weekly time was 28.5 weeks. Everything else is based on that referent being there. So if we had a male who was in Psych D, psychodynamic condition, then it would be 12.875 weeks less than the 28.5. So let's take a look at this interpretation of the results one piece at a time. The model information is at the bottom as usual. We have a significant F-test. The F statistic is 154.7. The degrees of freedom are 5 and 54. And the p-value is less than 0.001. The R-squared, the effect size, is 0.9347. So that's our whole, well, except for the confidence interval, that's our whole stats line for the model results. Next, we got to go into each predictor. And now the predictors tell us about the main effects and the interaction effects. The main effects are looking at just one predictor, not the interaction. So let's look at mean effects of gender. We come here, gender female, that line right there. There we go. We see that it's a significant mean effect for gender. The difference between male and female is 13.7. Females spend 13.7 more weeks on average than males, and it is a significant difference. So that's your B value, and there you go, like that. There is a main effect of difference in time in therapy between males and females. Then let's look at the mean effect for therapeutic condition. And that's going to be these two lines right here. So still talking about our referent, male. Males in control compared to males in Psych D, psychodynamic therapy, had a difference of 12.875, and it was significant. Males who were in the cognitive behavioral condition compared to control had a 15.5 difference, less weeks than control, and that was a significant difference. So we have some main effects of therapeutic condition. We have our B and our p-value, and we know we can get the average because we already did our descript cell means, so we already have the means. Okay, so what is this interaction effect here? We have one that is significant, the one for gender female. and cognitive behavioral condition. So we see that there's a significant interaction effect for cog-behavioral female, and that's our B 1341 negative and p-value less than 0.001. Now, how do we interpret interactions? We have to delve further into them. So whenever you see a significant interaction, you kind of just indicate there was a significant interaction, and then you would later on in your write-up let the reader know the results of probing or investigating that interaction effect. So we'll come back to interactions because we have one that is significant, at least one. So what we don't have, we don't know time in therapy between cog-behavioral and psych-D, psychodynamic. So we need to relevel. And it seems that cognitive behavioral has some stuff going on with that significant interaction. So that's the one I'm going to put as the new referent. So I moved it up to the front, and like I said, in R, treatment is default. So let's just see what it says now. So now we have cog behavioral as our referent and still male as the gender referent. So now I'm ready for regression number 2, and the referents are cog behavioral and male. This one I named time by CBM, so cognitive behavioral male. And we'll take a look at this. Again, your model level results are not going to change. They'll be the same. The predictor effects. Now we have no main effect for gender. We do have a main effect for when between cog behavioral and control. And again, this is for male. And now we have 2 interaction effects down here for gender female who's in the control condition and gender female who's in the psychodynamic condition. So again, we let our reader know that there are significant interaction effects, but then we have to go into investigating more specifically those interaction effects. And to do that, we're going to be using some new packages. Estimated marginal means and evaluating simple effects. So I'm loading EM means, and what I'm making here, what does this say? Because EM means is this package that calculates predicted values for each cell's average time in therapy. And also the multiply part tells the function that we want the predicted values broken down by all potential combinations. So that's what we're making first. And let's take a look at it. So here we have the mean for cognitive behavioral male, the mean for control male, the psych-D male, and so on. Now, what is the difference here between this information and what we got before with our cell means when we were doing descriptives? Bring it up so you can see it. So we had the mean, but here when we did descriptives, we got the standard deviation, right? And that's that distribution of the outcome of therapy time, the average therapy time, and how it's distributed. The difference here is this guy. This is the standard error. It's very similar to standard deviation, but because we are estimating the potential average time in therapy for this condition of cognitive behavioral when male, this is an estimate. The standard error of the estimate is how far, it's kind of like a confidence interval, right? If that's a very big standard error, it means that it's not sure about that estimate. And they also gave you the lower and upper confidence interval for the estimate. So when you're making a table, you would use the estimate, the EM mean estimate, and the SE. Let's see what that looks like. There we go. So this is me starting on my table. I got my title, my table number. It still has some formatting I need to do, but I can put in the mean and the standard error and male and female and my different conditions of therapeutic approach. Okay. Alrighty, what's next here? So to investigate the significant interactions, what we're going to do is probe the interaction by looking at the simple effects of the differences. And it's a different type of contrast sum or contrast function, not a treatment coding or anything. And when you look at the SPSS video, it's similar to the split file. So first we're going to look at the comparisons organized by therapeutic condition. And this says I want to contrast using what we just made with the estimated means function. I want to look at pairwise by condition, which is organized by the condition part, and adjust none. Running that, we can see these contrasts below. And notice that there's no significant p-value here. So for cog behavioral, the difference between male and female is not significant. But for the control condition, those in therapeutic condition control, there is a significant p-value. So there is differences in therapy time between male and female depending on when they're in the control therapeutic condition. And the same here. We have a significant difference between males and females on therapy time, depending on them being in the psychodynamic therapeutic condition. And that's what we mean by an interaction, that the differences of one predictor is dependent on the level of the other predictor. So let's look at it differently, organized by gender. So I'm taking that same code from the prior one, but now I'm organizing by gender. So here, when gender is male, there's a significant difference between cog behavioral and control, and between control and psych D. But not a significant difference between cognitive behavioral and psychodynamic when male. So it's a conditional effect. Here with female, all of these ended up significantly different. Cognitive behavioral to control, cognitive behavioral to psych D, and control to psych D. So that's what you want to go into detail with on your write-up after you tell the reader that you had a significant interaction. You probe it and find out exactly when that significant interaction is at play. So a couple more things we need to do because we have a significant interaction. We need to create some interaction plots so that we have a way to visually describe the differences going on there due to the categorical predictors. What you'll need is the package called interactions. And what I'm saying here is I want a plot that uses categorical predictors. I'm going to take that same regression that I've already made, time by cognitive behavioral male, and I'm letting R know that the predictor is gender and the moderator is condition. Typically you put the moderator with the one with more levels. and we'll see it again in our moderation lab later on. Okay, so running this kind of looks like this. So cognitive behavioral between male and female, control between male and female, and psychodynamic between male and female. Now we can add some other aesthetics to help convey what's going on there. If I add plot points, it would look something like this. And I can add a line between them. And that one helps out a lot, right? We can see that at least for control and psychodynamic therapeutic approaches, we have almost a very similar slope. Like there's a main effect of condition, but really the distance right here for male was kind of the same distance for female. Whereas when we look at this line between these lines, you see how this is the same for male and female. So there's where your interaction is really interesting. It depended on both gender and condition. Okay, so what is missing at this point? We still need our confidence interval for the R² effect size of the model. And in RStudio, we just run mbes and go get our R² from the model results. And we have 5 predictors. Scroll back up to one of these. Yeah. So we have our intercept, and then we have all of those estimates of regression weights. And then our sample size was 60. So when you run that, we see that our lower limit was 0.88, and our upper limit was 0.96, and that would be what we need for our write-up. And you can check the write-up on the lab sheet, and that is it for this video.